to okay, and if you want to speak or ask a question or share some viewpoints, what I would suggest doing, there's two ways you can do this. You could raise your hand and I'll try to track that, or you can also put questions or comments in the chat and I'll try to monitor that as well, maybe with Joanna's help. So what I'm going to do is I'm going to now introduce our two speakers. First, we're going to have Dr. Amin Madani, and he's an endocrine and acute care surgeon at University Health Network. He's an assistant professor in Department of Surgery and has cross appointments at the Department of Computer Science and Mechanical and Industrial Engineering. He's the director of the Surgical AI Research Academy, or SARA, which focuses on the use of technology to optimize performance in the operating room. And this includes platforms that incorporate machine learning, computer vision, advanced simulation, and augmented virtual and mixed reality. Also presenting today is Dr. Dale Podolsky, who's a craniofacial and cleft surgeon at the Hospital for Sick Children. He's assistant professor in the Department of Surgery and has cross appointments in Mechanical and Industrial Engineering and the Institute of Biomedical Engineering. As a trained engineer, Dale's work focuses on novel robotic applications for surgical care. He developed a high-fidelity simulator during his PhD, which is later commercialized as a part of a company he founded, Simulator Medical, and was sold for use in over 60 countries. He's currently lead of the Institute for Craniofacial and Cleft Innovation and the co-director of the Podolsky Center for Guided Innovation and Therapeutic Intervention. And so I'll welcome these two speakers, and we're going to start with Dr. Madani. Take it away.
There we go. Thank you so much for this really great opportunity and for that introduction. Can you guys hear my audio okay? Yeah,
we
perfect.
can.
Excellent. Okay, basically, yeah, I think I'll just give a little bit of background about what I do. And my plan was to give an overview of some of the innovations we do in the lab and some of our commercialization plans to take those innovations to the market. A little bit of information. I run a lab, like you said, Cari, in surgical AI at UHN, and it's really at that intersection of surgical education, patient safety, and technology. We use a lot of things like machine learning, computer vision. Then the aim of the lab is really to improve surgeon performance in the OR. So that's kind of a background around what I do. And I do endocrine surgery and acute care surgery. So let's talk about the first use case. And by the way, just a disclosure here, by no means am I going to pretend like I know it all about commercialization. It's entrepreneurship is very much a new area for me. So I'm still learning a lot of the processes, and my aim here is to kind of present the process that I'm going through, some of the many questions and obstacles that have come up along the way, and kind of open it up to discussion to hear people's thoughts. So the first use case we'll talk about is around surgical AI for performance augmentation. This is basically this concept of intraoperative complications. A lot of them are related to intraoperative decision support and things of that nature that are oftentimes preventable. So there's this idea that if you could intervene at the time of surgery to provide intraoperative support, guidance, or something like, hey, you may want to think of a different way of doing this. Or think about this, or I've detected an alert that would lead to a complication. That's the idea, is to improve your performance that way and perform patient outcomes. And the data is pretty overwhelming that most complications are related to decision making, situational awareness, and those kinds of things. So a lot of my work in the lab has been around this, developing basically AI algorithms to identify the surgical field and make sense of what's happening and make an assessment of that scene. Probably we've done a lot of different surgical use cases, whether it's neurosurgery or bariatric surgery or gallbladder, colorectal, thoracics, you name it. Probably our flagship product is this one, the Lab Coli one. And that's the one that's like the most ready to go into commercialization. So it's called Go No Go Net for lab colis. What does it mean? It's basically an AI algorithm that analyzes the surgical field during a gallbladder operation and tells you where it's safe to dissect, which is this green area, and then where it's unsafe to dissect, the red area. So go and no go zones. And the idea is to avoid major bile duct injuries, to make sure people keep their dissection above that line of safety, which is that interface between red and green. And then the latest iteration of the model basically also identifies where you interact with the tissue and your instruments. So it can basically assess where you're dissecting, when you're dissecting, how you're dissecting with respect to those go and no go zones. Now that's the AI algorithm. The other backdrop to this innovation is also the infrastructure around it. We realized there was no infrastructure to deploy this technology in the operating room, so we've created a whole end-to-end pipeline around this. Everything from the data acquisition, the machine learning pipeline, the library of AI models that then get deployed into a real-world setting. And there's two real-world settings here. One is live in the operating room to provide guidance on your monitor, and the other one is on post-operative video analysis, analyzing your video, your performance, and for coaching. This is what it looks like. This is kind of like your data portal where your data, it's like your Dropbox for surgical videos. And then you've got these data analytics that can come from go and no-go zones analysis to tell you where you dissected, how safe you were, what areas could you have improved on. And you can also use it during the surgery live as well. And this is what the innovation looks like. You've got this box that's like plug and play, and then it'll plug into whatever system you have in the operating room. And then the way you like your remote control is an app that you pair with the box. So it's kind of like your app store where you can select a menu of AI algorithms to run, whenever you want, on your monitor. And you can start and stop it and choose all the settings and colors and so on. So basically, what is it? It's, to summarize, you've got the raw AI algorithms, and then you've got a whole deployment pipeline in real time in the operating room and for surgical video analysis. So I'll stop there. That's kind of the innovation, the unmet need, and what we've created. And so there's been a lot of discussions that have taken place over the last few years about where we're going with this and how do we scale this technology. Um, um, Maybe I don't know if Cari, you want to stop here and ask the questions, but I think, I'm happy to ask them as well and answer them as I go along.
Yeah, why don't you go ahead?
Sure. So I think, I think the first question that's come up, and I'm looking at this purely from an entrepreneurial perspective as opposed to a scientific perspective. The first question is like, what is the product? Like there was a lot of intellectual property all over the place. Like there's AI models, there's a box, there's a pipeline, there's cloud, there's all these things. And I think the first thing is we have to really define what is the thing that, what is the product, a product that would be sold and commercialized and produced. And I think if you break it down, you've got the infrastructure, you've got the hardware, you've got the pipelines. That's one. And then you've got the actual raw AI algorithms itself. And I think you have to kind of make a distinctions between those two things because they have both have different IP considerations and both have different commercialization options available. From an IP perspective, if you ask yourself like what's patentable here, you can't really the AI model in and of itself cannot be patented. I think after a lot of discussions with patent attorneys and experts, the AI models themselves are more amenable to things like trade secrets or copyright. Patents would be things like and then like something physical that where you maybe have incorporated the AI model, so like the box and all that stuff. That would be more along those lines. In terms of commercialization plans, we've considered different options, and obviously I can't go into details due to the confidential nature of those conversations. But there's a few different options that have come up in terms of do we start our own company and start doing this? There's a lot of challenges there. Obviously, one of the big challenges with surgical AI is the market is very new. No one really knows what the return on investment is on deploying this technology in the OR. Like there are some AI models like polyp detection in colonoscopy, where there's a lot of data to support that. But in AI for surgery is very different. There's no studies actually that suggest that they can improve, performance of surgeons or improve patient outcomes. So you got to take that into consideration in terms of, creating a startup and a company and going that way. Another option is considering licensing this. There's been a lot of companies that have been, that have approached about taking this and incorporating this into an already existing digital surgeries platform that they currently have in the operating room. So kind of becoming like an add-on feature. So that's another way you can potentially commercialize something like that. And the other option is to just write out, sell it, not create a startup, but just sell it, and then just continue being I guess, an academic. So those are kind of like the high level considerations in terms of entrepreneurship of a lot of this kind of, it's a very new field. So we're still kind of figuring out what's the best way to do it. But anyways, maybe I'll stop there and I'd love to hear some thoughts, discussions, questions.
So while people are thinking questions, I'll ask one. One of the things that often comes up is risk, right? And the legal risk to presenting these algorithms, because AI algorithms work and the segmentation works most of the time, but there are failures in it. And so what are the liabilities with, going towards commercialization and the responsibilities of the company versus, the surgeon who's actually doing the operation?
Yeah, I had the short answer is I don't know the answer to that, but absolutely, because you have to think about, it's just like creating any other medical device. You have to make sure that I'm sure there's a process for Health Canada or other regulatory approval agencies in order to make sure that you do things properly. So I think that will be part of the pathway when it comes to commercializing this, to do the proper testings, make sure that it's robust, it doesn't fail in the OR. Like one of the initial problems we had when we tried to deploy this, it actually like turned the entire monitor in the OR gray. So you can imagine like if that happens in the OR and there's a major complication, like that can't happen. So you have to do all the testing, show the data to make sure that you get your FDA approval or whatever it is. So that's one aspect of it. But I think one other piece is at the end of the day, this is just decision support. So it's just like, any other medical device that would give, I don't know, diagnostic, data or modeling of anything. I think this, at the end of the day, it's the surgeon that has to take that into account and decide whether it makes sense or not, and who makes the decision on what to do for the patient. I think AI in surgery, especially, is going through this process where we're trying to figure out how best to incorporate this in the OR. I think it's important to be very transparent around what the model predictions are, like if it's very confident, if it's not confident, and that's all part of the design of the interface. Is you don't want an algorithm that'll tell you definitely cut there, when it's not really safe to do so. So we've made sure to include a lot of the probabilities of predicting what's a safe and unsafe area, for instance. But anyways, that's, I think, in terms of risk and liability, the field is really evolving, and I think we're still trying to figure that part out.
I'm going to read a question from. Oh, go ahead.
Yeah, I had a question related to what you just said, because I was hoping you would address that, because I've been kind of thinking about large language models and how to tease out how confident they are about their answers. And if, from what I'm reading, it's mostly kind of a self-coherence kind of measure, because they're basically they're token prediction engines. They don't give the truth. Can you expand a little bit more on how you might deal with that and how you might want to present the confidence of the information that's provided through your interfaces?
Yeah, absolutely. I mean, I can't comment too much on large language models because it's outside my area, but certainly in computer vision, we've explored this, and we did actually some design studies where we actually showed different user interfaces, asked experts, we did qualitative interviews, and focus groups, ask them, okay, if you've got AI, how do you want that data? If it models 50% confidence, how do you want that data? So there's a lot of design considerations into it. I think the one that we landed on that works the nicest is I'll show you. Um, it's kind of like um, first we started off with this, which didn't work out well. Like this bottom one here, where you can see a heat map. But as you can imagine, like a heat map like that is very, like you can't use that while you're doing surgery. Maybe it might be good for like a snapshot, but
Hmm.
that visual data, it's good maybe for a snapshot, but not for an ongoing surgery. So then we said, how can we incorporate? So we incorporate into the transparency and the opaqueness of the information that's presented. So the more opaque it is, the more confident it is, for instance. That's
Understood.
that's how we decided it would make the most sense. And then the other thing is the user interface. When people actually go here and they decide on how they want their AI to kind of show, um, I don't know if you can see, but basically, you can decide a threshold on your model. You can say only tell me where to go or not to go, if you're greater than, I don't know, 90% confident. So we've incorporated that piece into it because that was important for some of the surgeon end users. So yeah, confidence is figuring out what way to display that in a very user-friendly way is, I think, very, very key. Um, I don't know if that answers your question.
No, it does. But the when I saw the way that you did it, though, my only potential concern, I presume you thought about this already, is that how will transparency be perceived similarly in a scene that is highly lit versus ones that is not very lit up, depending on where the surgical light is pointing or whatever.
Um, I, I mean, I don't think we've explored that exactly, but usually it's pretty easy to tell. Like, as a transparency, the color is pretty consistent regardless
Uh-huh.
of the white balance. Like with the overlay that you get is pretty consistent, regardless of um, uh, what the surgical field shows and the white balance and all that. I don't think we've encountered that yet, but definitely we'll look into it.
I'm going
Thanks
to
for
Thank
ask
you.
a couple of questions just from the chat and then Sierra, and then we should move on because I know you have a couple more use cases. So Stan Hamster asks, how much standardization of practice does there need to be in a particular type of operation for this to be scalable and marketable?
So again, how
How
much
much standardization
standardization?
of practice does there need to be in a particular type of operation for it to be scalable and marketable? Like, does everyone do the
Right.
operation in the same way so
Yeah.
that those no-go zones would be the same?
Right. So I think standardization of the operation can be, it doesn't have to be a must. Like there's certainly in surgery, there's so much heterogeneity in the way surgeries are done. Everybody's got a different ways. Everybody has a special technique. And this is where educational theory and really understanding the unmet problem is very important. This concept of safe, unsafe, go no go is a pretty universal one, regardless of how you approach the gallbladder. Whether you like to approach it from from the lateral, the medial, this go and no go is pretty consistent. So the key is to identify areas that are like specific cognitive behaviors that are very high yield, very critical to patient safety, and use those as really the areas to target most. And that's what Go No Go was designed. Like we did a lot of the preliminary data on surgical expertise, which basically created the pathway to create this AI model. And I think that's a very important point because you shouldn't design a AI model just because it looks cool. It's but based on an underlying unmet problem. And anyways, it's a very universal one, this one. It doesn't have to do with if you like this instrument or that instrument or this approach or that approach.
That's fantastic. So one more from the chat. Jazdeep asked, have any studies been completed so far showing this technology has better outcomes than surgery without AI software? Have you gotten to that point yet?
Yeah, so we've done two. One is a more of a silent trial, if you will, where we looked at, I guess, retrospectively done videos and analyzed if AI was there, how would it make predictions. But that's also not a very good way because just because AI was there, it doesn't mean people would have activated it, listened to it, and actually done it. So we're currently doing actually a randomized control trial right now and we're 60% through our patient recruitment. One thing I will tell you is, even when AI is there and it's like literally plug and play, it's really like people don't actually use it that much. As much as I'm a proponent of this technology, like people don't actually use it. I think there needs to be we need to go through a phase where there's like more of an acceptance and like it's a new thing. So most people are kind of more hesitant to actually use it in an actually critical operation. So I'm not sure we will actually show improvement in patient outcomes or surrogates of patient outcomes like safety profiles during surgery.
Okay, last quick one, Sierra, and then we'll move on to your second use case.
Yeah.
You actually led beautifully into my question. I was going to ask about user receptivity to the new technology. I mean, surgeons, let's say any healthcare worker, but clinicians in particular can be hesitant to adopt new technologies, particularly in critical surgeries, particularly things that like this might obscure their otherwise, standardized surgical views. How are there measures that you've taken to address that? Are there strategies that you've looked into or employed in that respect?
Yeah, absolutely. And yeah, people are hesitant. Even I'm hesitant as well at the beginning. It takes a lot of sort of convincing and to show them that it works. It's not gonna, take away from the workflow of the OR and a lot of user testing, a lot of like, let me show you how it works, and then taking their feedbacks, being receptive to the feedback. And what's so funny is everybody has a different perspective on how they want the AI. Some people want it all the time. Some people don't want it at all, only some and when necessary. Some people want it as a fly on the wall that just jumps in only when it detects something bad. I don't know the real answer to that. I think we're still learning what's the optimal design, but certainly we've done a lot of investigations and user testing to try to figure that out. I think the results of that trial are probably going to be there's no difference, and mostly because it wasn't really used as much as it could be. Was it used, it would have led to better performance. But I think that's the kind of the lesson is we still need to figure that part out. Sorry, I don't have a good answer to that question.
No, it's great. Let's go on to case 2. I'm just looking at the time.
Yeah, maybe we'll just limit it to case 2 if that's okay, just to leave time for Dale's presentation as well. Is that okay?
Well, let's go on to case 2. We'll see what time we have.
Okay, sounds good. Use is the use of digital twins for preoperative planning and simulation. So this is basically this concept of doing 3D reconstructions using preoperative anatomy like MRI, CT scans, and things like that, and using it for to be able to do recons and using it for either rehearsing an operation, planning, showing it to patients to explain to them what you're going to do for them, being able to use it for simulation training and so on. I'll skip over that for interest's sake, but there's a lot of challenges to doing 3D reconstruction. It's not new. It's been done for many years. But automating that in a way that allows an average surgeon who doesn't have the technical, skill set to do programming and any of those things to, point of care to do it is the novelty here. So we created a whole infrastructure again around that goes to your PACS. You select the AI model that you want. And then you select the CT scan or MRI that you want to use, and then boom, you get a 3D reconstruction. And you can bring it into your operating room, rotate it around, do all sorts of fancy things. This is just kind of a use case for, I think it's MRI of the shoulder. And the thing with this is you can actually because you don't have AI models that'll do that for every possible cancer that can possibly happen. So sometimes you also have to select the tumor that you want. So you can bring your PACS and select the tumor and then basically it'll reconstruct that for you. So here you can see the tumor, the shoulder, the bones, and things like that. This is a use case of an adrenalectomy that I did. I was able to identify the tumor on my CT, and then in one shot, I was able to get a reconstruction to plan my surgery, know exactly what angles to put my ports in, and so on. In breast surgery, this is really going to be, I think, useful to localize the tumor. and be able to kind of reconstruct things, and also be able to do other things like being able to map out what's the distance from the skin to the tumor, how thick to create your flaps. So we're doing a lot of different novel things in that. And also we're adding the physics into the digital twins. So we can actually do a mock resection, reconstruct it, and so people can actually show what the cosmetic outcome will look like. That'll be sort of down the line. And then we're actually doing digital twins as well to use it for surgical education. So you can actually take a video of your surgery, in this case, a gallbladder, and discuss with trainees how to retract the gallbladder. So it's like a one step further for video review. Okay, lots on digital twins. Again, there's a lot of different things. A lot of the problems around what is the product. There's in this case, to me, there's the actual AI models, the ones at least that we develop internally, like the breast reconstruction one. That one's novel. There is also the entire pipeline and the whole integration. That to me is sort of like a novelty that we're trying to figure out how to not only protect the IP but also commercialize this. Digital surgery is a very booming field. There's a lot of actors in this area, and certainly there are companies that have already started 3D reconstruction services. So I think having a scalable pipeline that doesn't require you to send your MRIs to a company to reconstruct is certainly novel. And I think we're looking at more licensing as a potential commercialization option there. I think the key is to work with potentially a company that already has a distribution pipeline into different operating rooms and add that sort of like an added feature. But certainly this is a newer area that we're exploring in. Yeah, maybe I'll stop there.
So I think Jazz had a question for the last part, but I think it's relevant to here too. And it says, from a deep learning perspective, what's under the hood? So are you using traditional machine learning algorithms, neural networks? Is it a hybrid approach? Are you using, I guess my addition to that question is, are you using open source technology, open source algorithms, or, how do these work, or how do you integrate all of that when new models are coming out all the time?
Yeah, great question. So basically, so the pipeline is set up to be any AI model. So you're right. If there's something like we've incorporated open source models into this, we have our own ones that we developed internally, and so you don't want to reinvent the wheel. If somebody has developed a really good segmentation algorithm for, I don't know, shoulder, you don't want to redo that one, or they want to use that model for the reconstructions. So it's designed to be a universal platform that incorporates any AI model. The AI model is both automated and semi-automated. The automation part is for very routine anatomy that can be automated. However, you can't, at least not now, you can develop an AI model that'll do everything. Like for instance, for my case, doing the adrenal vein is not we don't have an AI model that'll segment that automatically. Or tumors. We don't have AI models that'll segment every tumor that is known. So for that, we use foundation models like MedSam2 that'll basically, you just point and click and it'll take your targeted structures and do that for you.
Terrific. Why don't we quickly go to your third use case, because I think people want to see it.
Okay, sounds good. Dale, I promised to zip through this to give time for your talk. The last innovation is around AI for workflow and disaster management. A little bit different from intraoperative. This is more around resource management, teamwork, and things like that. So the use case here it started with mass casualty incidents like traumas, civilian disasters, bombing, mass shootings, things like that. And this idea that you've got suddenly a surge in capacity where you've got like 300 victims that need to be triaged and dispatched to different surrounding hospitals. You've got, patient factors to consider, who's critical, who's not. Obviously, the critical ones should go to the level 1 trauma centers. You've got transportation factors, how many ambulances, helicopters, and so on. And then you've got hospital factors, who's got OR capacity, who's got surgeons available, who's got ICU beds available. So you can understand it's like a very complex decision-making process that takes place. And it may not be hard for like two 2 victims. But when you've got 300 people to dispatch, it can be cognitive overload. And right now, the way this is done is through tabletop exercises, at least for simulation training. But even in a real life case, coordination is a big challenge. Just how to bring the team together to coordinate. So long story short, we did 2 things. Step one was, can we actually accelerate the process using AI machine learning to train it to become really good at being able to identify who needs to go where, and optimize things like survival probability, go to places that have the specialty cares requirements, places that have, don't send somebody who needs a ventilator to a place that doesn't have any more ventilators, send a burn patient to a burn center, and so on, and to kind of try to optimize that. And I won't go through the details of the AI model, but basically we trained it to do that on hundreds of thousands of simulations. And basically the product here is a digital ecosystem. It's like a product a software as a service, if you will. It's like think about it as like a multiplayer video game, like Age of Empires, where you have like multiple people coming together and playing the game together. You've got like a commander who makes high level decisions and decides who to go to which hospital. You've got somebody at the disaster site that triages people. And then you've got people at the hospitals who update the resources at each hospital. And basically, the way it works is you've got AI integrated into it where you can either manually drag people into different hospitals, or you can say, AI, where do you send it? And it'll automatically give you suggestions and with explanations as to why it's the best place to send it and alternative options. And so it's like a human in the loop. And then for the, other players, you can have like, instead of typing in data, your AI will basically take your description of the patient and create automated patient profiles and so on. And then you can do other things like track people, as they're being transferred from one place to another. If there's like a bombing somewhere, you can close off roads so the hospitals can avoid it. If there's military activity, you can create military activity and so on. If it's like a place like the military, you have medevac, chain of evacuation, where it sends you to one place, then another, like with the mobile units and so on. So basically, the use cases here are things like mass casualty disasters. The military has been quite interested in this for evacuating personnel. Also, if God forbid, there's a war and there's like thousands of people that need to be repatriated back to Canada, where do you send them? And also, like, let's say you have public health emergency like COVID, where are the hotspot? Where can you redistribute? The product here is, it's more of a platform. It's web-based. A lot of the IP is around mostly, I don't think there's a lot to patent, but we're still exploring those options. There's not a whole lot of physicality to this. It's all a sort of, cloud hosted thing. And in terms of commercialization, we're still very, very early, so we still don't have a lot of answers there, but there's a lot of options here. Military would be, is a good option to explore, working with jurisdictions like the ministry. I think looking at those partners is probably a better commercialization plan than purely looking at it as a purely educational tool. So anyways, I know we're short on time, so I'm just kind of zipping through this quickly, but happy to answer questions around that.
That was super interesting, actually. And did you take learnings from other fields to develop this, like from air traffic control or from other, disaster management or other fields that came into putting all of this together? Or was it just your knowledge of, from a medical perspective of disaster management?
Yeah, I think certainly, it's not just purely a medicine standpoint. Like, you got to work with people in EMS, people who have, like, military people really know this stuff inside out. Working with people who are high level, who have done a lot of disaster management, not just from medicine standpoint, but nurses has been really critical. So I think there's a lot of expertise here, and certainly I'm not a trauma surgeon, so we've been sort of talking to a lot of end users to gather those learnings. A lot of people, this is like an industrial engineering project almost, where speaking to people who have experience in optimization of workflows in like factories and industries. So a lot of those learnings have come into play as well.
Super interesting stuff. So in the interest of time, I'm going to switch over. Dale, do you want to share screen? Thanks so much.
Yeah.
That was some great cases.
Thank you for having me.
All right. Yeah, that was very interesting. I always learn something new from you. Okay, let me share my slides. Share screen. Screen 2. Just let me get to presenter view. You see presenter view? Or not presenter view, the slides.
Perfect. Yeah,
Good.
looks good.
Okay, perfect. Yeah, so this is going to be a really brief talk. It's going to be high level. I'm going to just provide an overview of surgical robotics. What are the interesting aspects of surgical robotics from a technical perspective, and where I see the future of robotics, and a little bit about what I do in the lab. So as Cari mentioned, I lead a large surgical robotics lab at SickKids. My research is in surgical robotics simulation, medical device design, and I'm also a craniofacial surgeon. So this is a boring slide. Really quickly, the history of surgical robotics, it started with just using industrial manipulators, mainly for more precise brain biopsies. And actually, one of the pioneers of this was Dr. Jim Drake, who's recently retired, but a neurosurgeon at SickKids. And the genesis of surgical robotics was really for space medicine, right? To do remote surgery. There was a lot of funding from the military in the United States, and Intuitive Surgical, which started from a merging of two different earlier companies, is really being, the genesis and the driver of this industry, right? So Intuitive Surgical, they create the Da Vinci robot. It is by far the most commonly used surgical robot around the world. They have a monopoly on the industry, okay? They are a typical example of a monopoly, but for anyone who's used the Da Vinci, and that's most robotic surgeons, it is a remarkable machine. And I've had the opportunity to visit the factory down at Intuitive to see how they build this machine, and it is really a marvel of engineering. It's been around for about 25 years. There's multiple iterations. These are the most commonly used multi-port systems, the Da Vinci Xi and the Da Vinci 5. And I wanted to just bring to your attention that Intuitive has over 7,000 patents, and they've essentially created a patent wall that has made it very difficult for other companies to get into this market up until about 5 years ago. And remember, their first generation system was FDA approved in around 2000. And so in about 2019, a lot of their major patents ran out, and you started to see these clones of the Da Vinci popping up around the world. But again, I just want to stress, even though it is a monopoly, it really is a remarkable piece of engineering. And what fascinates me, and really what is the heart of this technology, is these wristed instruments, right? So this has been a replacement for a lot of laparoscopic surgical procedures, and the capability or the advancement is the integration of these wristed tools, right? So this is a Da Vinci instrument, and this is 8 millimeters in diameter, right? And these are cable actuated, so that big machine that you see here essentially actuates this wrist. We call it a wrist. It operates like a human hand, like a tiny human hand that can operate within workspaces, right? So within the abdominal cavity, the pelvic cavity, also the transoral space. And so this was really essentially what the magic of this machine is, right? So this $170 billion company, most of their technology is to drive these tiny wristed instruments, which gives it these additional capabilities. And there's other things. There's vision systems. There's endoscopes. There's integration of certain aspects of machine learning that are coming into play. But this is the heart of the machine. $170 billion, 30 years of research into getting these tiny wrists to move. There's a classification in robotics. This is not exhaustive, but you look at the multi-port system on the left, which is you have multiple instruments that are far apart from each other, where you have an incision for each trocar to enter a body cavity, versus a single port system, which is what you see on the right. And these are newer systems, these single port systems. And For this is single incision surgery, where you have a single port where all instruments traverse through a single trocar. But you can imagine if you have multiple arms working through a single trocar, it's going to require more advanced technology to get those instruments to move within a tinier space. And so surgical robotics is really starting to evolve, especially over the last 6 to 7 years, as some of these patents have run out and there's been growing interest in other areas. The Da Vinci is used for general surgical procedures, so those typical laparoscopic procedures for pelvic abdominal surgery. And we have these new areas, and this is just one example. So microsurgical robotics, and this is an FDA-approved system called the Samani by MMI. It was developed in Italy. And I mentioned that the Da Vinci instruments are 8 millimeters in diameter. These instruments are 3 millimeters in diameter and are built purely for microsurgical anastomosis. So you can see the technological advancement of being able to manufacture and produce the parts required to make these highly dexterous tools at this scale. And it's a very difficult thing. Think about 3 millimeters on a ruler, right? To create a tool that has the capability to function as a wrist is a very difficult thing. This is another example of a clinically used microsurgical robot. So those are just examples. There's other areas in endovascular surgery. There's bone cutting robots. I don't want to be too exhausted here because I want to get to the discussion. But when I started in this area in 2014, the Da Vinci was really the only system available. It was about 15 years old, and robotic surgery was very controversial, right? People thought it was too costly. There wasn't a lot of evidence that it was superior to non-robotic approaches. And when I look at the landscape now, it is clear to me that robotics is the future of surgery, of all surgical procedures. It's going to take time to get there, but I think we're already seeing that happen. There's going to be smaller, more capable and dexterous instruments, the implementation of advanced vision systems. And if you think about the robot, it's a machine, obviously, right? And having that machine capability, you're going to have the integration of machine learning and then automation, as well as navigation and path planning. And we can see this is just a prediction and a history of the surgical robotics market. We can see that it is rapidly expanding. And that's, I think, what we're all, there's a growing interest and there's much more acceptance of this technology as really the path forward. I really encourage you. Science Robotics is the highest impact factor journal, technical journal for robotics in general. And then there was an issue in July on surgical robotics. It's very interesting. And so some of the discussion points that I would like to highlight is, what does the future of robotic surgery look like? I mentioned some of these things. I think we're going to see enhanced automation. Automation in surgical robotics is a very difficult thing to do. And you mentioned this, it's very heterogeneous, right? And I think it would have to leverage some of the technology that you're working on. In terms of creating a startup or a company in surgical robotics, these are very difficult things very high capital requirements. It's estimated that you're going to require about $100 to $200 million in funding just to get a surgical robot approved, and probably more. And then there's really challenging regulatory hurdles, right? So, you may think to yourself, well, how can anyone, overcome these challenges, right? And there's a international robotics conference. This is the premier conference yearly. It's called ICRA, called International Conference on Robotics and Automation. It's in a different city around the world every single year. It happens in around the springtime. It's going to be in Austria in June. And I went to this conference in Atlanta last year. And it's not a surgical robotics specific conference. It's for all of robotics. And this is where you're going to see, what is the latest in robotics technology 5 years from now. It's really the latest and greatest. And someone presented that there are currently over 120 surgical robotic startups right now that are working towards developing these more advanced systems. Just really quickly on my own research, I developed this cleft palate simulator, initially developed for the purpose of developing a surgical robot, but it was also developed as a training tool. These are some examples of the use of the simulator in these large training scenarios. And then this technology and the company was acquired by SmileTrain and is being used in over 60 countries. I also developed these novel surgical robotic tools in many different areas. This is a pediatric specific robot we're very excited about because there is no pediatric. I think my daughter's coming home. I apologize for that. It's a doorknob, but this is a pediatric specific surgical robot we're working on, which we're very excited about because there is no surgical robot developed for pediatrics. The Da Vinci is used in pediatrics in limited cases, but it's too large. It was developed for adults. And this is the latest iteration of that. We're also working on bone cutting robots. And then really exciting, humanoid robots you're going to see them in the operating room. I think this is going to be, there's very few people working on this. We have one of these. It's a Unitree G1. We have a second one coming. And if you think about existing surgical robots like the Da Vinci, those are task-specific robots. But a humanoid is going to be a general purpose robot. So I think these are going to have a growing role in healthcare and in the operating room. All right, that's my talk.
So I'll start off the questions as we wait for others. So what do you think the use of those humanoid robots is going to be? Is it, is it passing instruments? Is it retracting? Yeah. Is it holding things really steady? What's their role going to be?
Yeah, I mean, I think all of the above. I think the use case here is all of the labor shortages, right? I think that's going to be a big driver of the use of humanoids. A humanoid is not going to get tired, right? It can work 24/7. There are now humanoids that exist that can change their own batteries, right? So I think that, I'm not going to go into too much detail about humanoids in general, but the critical aspect of the humanoid is the hand. So at that ICRA conference, there were 12 companies just developing the hands for the humanoids. And if you think about how complex the movement or the motion of the hand is, it's very difficult. You need sensors. So that is an area that I think there's a lot of opportunity for research, and that's what we're going to be looking at in particular. But yes, grasping, like to get a humanoid to automatically detect like a syringe, then pick up the syringe and then hand it to a surgeon is a very difficult thing to do, but it's very interesting.
Terrific. Norm?
Yeah, I have a question because, to me, the evolution of this is a little similar to surgical navigation in that people thought, it was going to be used in a lot of surgeries, and it turns out to be used in a subset of surgery. I'm just trying to picture in this new world that you showed us today, does that mean that surgical navigation will be just an integral part of all of this, and there'll be more of it?
Yes, I think, yeah, for sure. I mean, I think if I was looking at navigation, I would classify it into bone cutting robots versus soft tissue robots. Mm-hmm. Because I think in bone cutting robotics, navigation is already being used, right? Because it's much more easy. It's easier to segment bone and to do like path planning and preoperative planning. So I think in terms of robotics for bone cutting systems, it's going to be much easier. And that's already being used, right? I think for soft tissue robotics, I think, the challenge is there's limitations, and maybe, Amin, you can speak to this, but there's limitations in the imaging, right? And the ability to sort of segment different types of tissue accurately, right? So I don't know if you can comment on that, but I think it's more challenging for soft tissue and robotics for sure.
Yeah. Are you, sorry, when you say navigation, you mean intraoperatively, like on the surgical field while you're doing surgery, and navigation to tell you this is where the organ is and things like that?
Yeah, I mean, we're talking about, either a stealth station or something, where you might have planned on preoperative images, and then you do some kind of registration in the OR and, that kind of thing. Because it sounds like you might use it more in this new world, because it sounds like you're planning potentially more than you were in the past.
Yeah, that's certainly a lot harder in soft tissues because, like you said, it's very deformable tissues. So what you saw in your CT is certainly not what you're going to see in your operative field. Whereas bone, like you said, it doesn't really, I don't know, I'm not an orthopod, but doesn't really change shapes, I assume, whether you're insufflating or looking with the camera or whatever. But when you put it in the abdomen, the bowel will move. But certain areas like kidney, like nephrectomy, Certainly, people have used it for operative navigation to tell you where, for instance, is the people who want to do a partial nephrectomy, they can actually model where the blood flow will be, so that you can cut the kidney in the right place to take just a superior pull or something like that. But the kidney is a less deformable organ. Liver is similar as well. People have looked into that as well. So yeah, I think it's becoming more and more prominent, but certainly a lot more challenging, like you said, Dale, than other areas.
And then
Yes.
just one more thing to add is I think automation, it has to have navigation and preoperative planning. It's a mandatory component of it.
Jess?
Thanks, Dale. What's your estimate for timeline when humanoid robots can actually do the entire surgery? Like if you listen to Elon Musk talk about Tesla Optimus, he says within 3 to 5 years, Optimus will be able to operate the same level as the best surgeons in the world for common things. Is that
Yeah.
just crazy optimism, or do you see this happening in our careers?
Yeah, it's a great question. When you go to these ICER meetings, right, it's astounding at the rate of technological advancement and the amount of capital that's being poured into these technologies, right? So what the technology looks like now is going to be very different to the capabilities 5 years from now. I do think we have a tendency to sort of overestimate the capability right now and in the future. And I think it is still more primitive than we think for highly dexterous tasks like surgery. I think humanoids in manufacturing, where you have very reliable and predictable tasks, it's much easier, right? Like picking up a box. But as was already mentioned, right, surgery, we don't even fully understand surgery, right? And, hopefully these language models, it's not an area that I'm an expert in, right? But all of this is going to be elucidated at the same time using these new technologies. I think it's probably not going to happen within our careers. I think it's going to be longer than that. I feel like I'm more of a realist when it comes to these things. Elon Musk is a brilliant man, but I think based on his predictions, we should already have humans walking on the moon by now, or on Mars, right? These things are difficult, right?
Yeah,
Um,
sure.
so yeah, I
Thanks.
don't know if that answers your question.
No, that's great. Thank you.
I'll ask, there's a few in the chat. So here we have from Michael, do you think training with robotic systems will soon become a formal part of surgical residency training programs in the future? And what would that look like for trainees in practice?
Can you repeat that? Sorry about that.
Oh, so do you think training with robotic systems will soon become a formal part of surgical residency training programs in the future? And what would that look like for trainees in practice?
Yeah, that's a great question. Yes, I mean, I think, it's in the United States, in particular, a lot of their fellowship programs are specifically geared towards robotic surgery, right? And I know that new surgeons or surgeons who are looking for jobs are looking for places that have access to a robot because that's part of their training, right? So I think we're seeing this more and more as an integral part of both the training and the actual practice itself and standard of care, right?
Interesting. Okay, so Amin asked, actually, I'll just say it for you. How do we reconcile the cost of robots with scalability? Is it really feasible for robots to be the future of surgery if they're too costly to scale to places outside tertiary care centers?
Yeah, that's the $1 million question, no pun intended. But yeah, there's no doubt that cost is a big barrier. And I think that's, as I said, Intuitive is a remarkable company. They've developed a remarkable machine, but they have a monopoly on the industry. And I think that is one of the reasons why costs are high, right? I mean, the Da Vinci costs $3 million, $200,000 a year in maintenance contracts, about $2,000 in disposable costs per case. It's cost prohibitive. But despite that, with all of the cost pressures, in particular in the United States, there are thousands of robots that exist, right? there are other market factors that are driving that. A lot of the, the care in the United States, as an example, is patient driven, right? So, for example, if someone thinks that having a robot do their surgery is going to be better, it doesn't matter what the evidence shows, right? And then, the insurance provider is going to be willing to pay that cost. But I think as these patents run out, as more and more companies develop this technology, when you look at the economics of scale, the cost should go down. And if you could do it automated, if you could do it faster, with less blood loss, lower morbidity, less time in hospital, shorter procedural time, all those things, costs go down. It's just the technology is not at that point yet, but it will be eventually.
I'm going to ask one more from the chat, and then Jazz, you'll have the last one. So this is from Alan. What precautions are you taking, if any, to ensure AI, and I think robotics would fit into this question too, remains an adjunct and not authoritative, which could become a medical legal issue? For example, shared liability.
Is that a question for me?
Could be for either of you. Sure, go ahead.
Well, I think I think right now, it's putting aside unless you're talking about automation. I think you're right now using it as a tool for augmentation of surgeons. So that automatically, it's on the surgeon. Like it's always going to be right now. Sorry, not always, until automation, humanoids take over, and a bunch of Terminators walk around the hospital. I think it's going to be really just like any other medical device where you decide it's a human in the loop. And if you have that technology available in your operating room, you use it however you deem fit based on the evidence available. And the companies are available to provide you with the service that you need. I think right now it's completely in that domain. Yeah, like I don't think AI is right now in an authoritative sort of position. At least not in the not in this area. No, but you can argue though and say, okay, but if the AI is very confident in telling you something, and then it really influences decisions, and people just kind of just automatically do what the AI says, then maybe it is in an authoritative way. And I think it's up to us as a profession to make sure we put up the proper guardrails of how to properly implement this, given the proper evidence available. So as much as I love the innovation, I think like Dale said, we're pragmatic about it, and also we have to do it in a very robust way. Otherwise, people will lose their confidence in the technology as well.
Okay, final comment, seeing the time, from Jazz.
Yeah, thanks to both speakers. That was it's a really great discussion. This is more of an observation from orthopedics. Within orthopedics, over the last several years, there's been an emergence of robotically assisted surgery, mainly for total knee replacement. I mean, these robots from like Zimmer, Stryker, you name it, different big companies have their own version of it, and they assist the surgeons in making different kinds of cuts and theoretically improve intraoperative accuracy and maybe some early reports of better outcomes. I don't do those particular surgeries, and I think Dr. Waddell was on the cut. I was going to get his perspective if he's still here, but if not, like the point I wanted to make was like patients really have awareness of these technologies. They seek out surgeons who use robotic assistance in the operating room, and it's like a self-fulfilling prophecy. Like surgeons who know how to use the robots become more popular, and the surgeons and the patients seek those people out. So actually, like there's a huge level of consumer acceptance and enthusiasm. And I'm wondering if you see that in other specialties, or what the general thought is. How will these be adopted among surgeons and patients?
Yeah, I mean, that's a really great point. And I think that was one of the big drivers of the early adoption and acceptance of the Da Vinci, mainly in the United States early on, because there was no evidence to support that it was better, right? And it takes time to prove that it's better. similar to laparoscopic surgery. These things in some ways seem obvious, but for the actual evidence to come to be, it takes time. And the Da Vinci is also very interesting because it was a solution to a problem that didn't exist, right? It was originally developed for cardiothoracic surgery and it found its role in pelvic surgery, right? And so something else was driving its adoption. And I think it was patient driven, a lot of it, right? Which I'm thankful for because I think it drove the technology. And I think the technology is here to stay and it's going to keep getting better. It's going to get cheaper with more capability. And I think the evidence is going to be stronger for its use. I really do think so. And I just think that, you're just talking to the average surgeon, 15 years ago, they were more skeptical about it. I don't think that's the case anymore. And just by sort of your commentary, it sounds like, what are your thoughts on it in general, right? Like, do you see a role for it in the future?
Yeah, I mean, I do. I mean, I think you're starting to see emerging, at least in my specialty, you're seeing emerging data that there are some elements of outcome that can improve, and patients want it. And if that's driving demand, and if there's perceived improvement in accuracy, the surgeons who use it feel more comfortable, especially for more challenging cases. It seems to be a win-win on both sides. So I think the supply and the demand side both like the technology because there's benefits for both sides. So I think it's inevitable. Like I don't know the rate at which things are changing is pretty profound. But how quickly will it be introduced into the clinical realm? I'm not sure. So, but I'm
So
looking forward to seeing you guys put out your work.
So on that note, it's amazing to think about innovation and entrepreneurship in these new fields in AI and robotics. I really want to thank our two speakers. It's been great. And thank you everyone for participating in this really interactive webinar. So with that, thanks so much and have a great night, everyone.
Thanks, Cari. Thanks, everyone.
Thank
Thanks,
you.
guys. Thanks, Cari.
Bye.